Today's lesson is on the quadratic formula. So I will explain what that is in a second. For now, we're just going to do kind of some warm-up exercises here, and we're going to go through and we're going to find the roots of these quadratics. Okay, so these are in standard form, and I want you to go through and find the roots. So basically, you need to go through and factor them. And then once you get the factors, I want you to pop out what would the x-intercepts, the roots, what would the roots be, okay? For this first one here, we're going to go through and we're looking at it and we're noticing that it's a simple trinomial, so we could think of, the different tools that we can use in order to solve this problem. Okay, so hopefully you're at the guess and check method, but if not, no worries. I'm just gonna go through, building the product sum table, all that stuff first. Okay, so I'm noticing it's a simple trinomial in the sense that there is just a 1 here, okay? I'm still gonna look for my greatest common factor though. Always make that check. Okay, and then you're noticing hopefully that the only thing that works here is just a 1, okay? 1, 4, and 12, just a 1 would work. So, and then no letters. All right, so from there, I want you to do the product and the sum and the product evaluation here. So again, you're trying to think of what would add to that middle one, -4, and then remember you multiply A and C to make -12. So what would multiply to make -12, but would add to make -4? So again, in your head, hopefully you can quickly think of the two numbers. If not, you list them all off. Okay. All right, 1 and 12, I can't add or subtract those to make 4, so that's no. 2 and 6, I can add them, I can make 8, but if I subtract them, I can make 4. So I know I have the right numbers here, so now I just got to figure out what sign, because here I need a -12. So the possibilities are, -2, +6, or +2 and -6. Okay, and then hopefully you've completed enough of these that if it's a negative, make the bigger number negative, and then you know that when they add up, you'll get the -4 coming out. Okay, all right, so from there, you guys know that this is a simple trinomial, so I don't even have to go through and do the decomposition method here. I can simply just write my two factors as +2 and -6, like that. Okay, so all right, so and then again, if you wanted to double check by doing FOIL and multiplying it back out to see if you get back to here, you'll find that yes, that's correct. That will work and get you to there. Okay, and then in the last cycle, we looked at finding the roots now. Okay, so this is the standard form. This is the factored form. So now I want you to find the roots. Okay, so I want you. Okay, so you're seeing here it's a nice simple factor. But again, if you can't remember how to do this, all you're doing is you're equaling these to 0. Okay, and then you solve it. And when you do that, you pop out the opposite. So -2. Okay, because this 2 would boot over here, and you get -2. All right, and so that's that one. And then the other one, this is the same as making this one equal to 0, and then solving for it, and you get +6, like that. Okay, so these are your two zeros. So you found your roots. Okay, so I'm using all the colors here today. So these are both your roots. Okay, so get comfortable with that word. I'll say solve. I might say find the roots. I might say find the x-intercepts. I might even say zeros. Find the zeros. Okay, so be ready for any of those instructions, and then know exactly what I mean by that. So solve, find the intercepts, find the zeros, find the roots, and so forth. Okay? All right, so let's move to the next one here. So already, I'm gonna just check for the greatest common factor first. Okay, so again, whenever you see the word solve, you should know it means factor it. Okay, so do it, get it to the factors like this, and then solve it, pop out with the answers here, okay? All right, here, okay, so 5, 17, and 6, nothing will work here, no letters will work, so now I'm going to move to the sum and product table. Okay, so I want to find, remember, this one oops, the one in the middle is the one that we have to add up to. Okay, so 17. But then the one we multiply to is the product of these two. Remember, it's A and C together. Okay, so we need to multiply to this number. So 30. Okay. All right, so again, this is a complex trinomial, so you can't use this trick where you go from the table right to the factors. Okay, we're going to have to use decomposition here. All right, so we have, our conditions are we have to multiply to 30, and we have to add to 17. So again, hopefully you can brainstorm and quickly think of the two numbers. If not, you just go through the process of going through and listing all the factors. So I'll start with 1. Okay, 1 and 30 will work. 2, does 2 go into 30? Yep, 2 and 15. Oh wait, if I add those, I will get 17. So I found my two factors now. Okay, so again, from here to here, don't do this now, okay? You can do it here because this was a simple trinomial. Here we can't do that. We have to actually go through the process of decomposition. Okay, but if you are guessing and checking now too, you don't even have to do this step. So just whatever you need to do, get this factored. Okay, so see how it's equal to 0. So that's the new thing about today's, I've got these equal to 0, right? So we're solving for the answers here. All right, so we're going through, and so I've decomposed the middle term, and now I am going to factor by grouping here. So we're going to start with this pair here, okay? The first two here, what can I divide out of both of them? Okay, 5 and 2 new numbers work, but they could both divide an x out. All right, and I'll do that in a sec. Let's look at the next pair here. Okay, we got 15 and 6. What can we divide out of both of those? 2, no, 3. 3 would work, right? An x, no, just a 3. All right, so now let's go through and factor these out. So here, I'll write it here where there's more space. Okay, so we have the x comes out. So I even actually have too many x equal signs, so I'm going to leave the equal sign there. So I'm going to put the x here. That factors out. And then what's left is 5x plus 2. Okay, and then I'm going to factor out the 3. And so that leaves me a 5x plus 2 as well. And then I'm going to factor out this, these two. So they have these two in common. So let's factor that out. And then we have our factors now. Okay, all right, but we're not done. We want to go through and find the factors, or those zeros, the roots here. Okay, so from there you need to find the zeros, okay, the roots, the x-intercepts. So what you're going to do here is, again, you guys know how to just pop this one out. It'll be the opposite sign, so that one's nice and easy. But be careful with this one here because there is something on the x here, so that's why I always tell you to have this backup plan here where you can, you equal it to 0 to remind yourself, oh yeah, I gotta solve for this 0, okay? So this 2 would move first, -2, then the 5 would move next, and then your answer is -2/5. Okay, so these are your two roots for this question here. Okay, so here's the next one. So again, we are going through and we're solving this quadratic. Okay, so if we are going to solve it, we go through the steps of getting it factored. Okay, so we're looking for a greatest common factor. 1, 2, and 5. Nope. Any letters? No. All right, so the next step is, I'm noticing it's a simple trinomial. All right, so I need to add to the middle term, -2, and then I need to multiply to -5 here. Okay, so from there I'm thinking all the different numbers that multiply to make 5. Okay, so I'm saying and then right now we're always looking for integers, right? So whole numbers with positives and negatives. So so anyway, 1 and 5, okay, that's the only thing that we can multiply to make 5, okay? So if I add these or if I subtract them, I will not get a 2 here. So there's no other factors that you can think of. So in the past you would write cannot be factored, okay? So you can't factor it into some nice, integer, fraction values and so forth. But using this method here. But we need to find the roots, okay? And what are roots? Well, the roots are x-intercepts. So let's go and graph this and see, if we graph this, are there actually x-intercepts here? So in order to quickly graph it, we're going to use Desmos. So again, just go to Google and type in DESMOS. Okay, and usually sometimes the graphing program comes up. If not, just go to here, click on the first Desmos, and then click on Start Graphing. Okay, so here it is. Just to show you here, I'm going to type in this first one here. So we have x squared, minus 4x minus 12. So again, when we went through and factored and solved it, we found the roots. But the roots, what those are the x-intercept. If we're taking a look here, we have -2 and 6. So those are the correct roots. Okay, let's go and do the next one as well. So I'll turn this one off, put on another one here. 5x squared plus 17x plus 6. Okay, so again, if I go through and look at the intercepts here, we have -3 and we have -0.4, okay, which is what the 2/5 is here, and the -3. Okay, but again, I always want you to write your answers in fraction form or, integer form like this. Don't go to decimal, okay? All right, so now this one here, we tried to do the sum and product table analysis, and we could not think of any factors that would work here. So again, in the past, we would write cannot be factored, and that was good. So, we want to, I don't want you to just factor it. I want you to actually find the roots. Are there some roots here? I want you to solve these. I want you to go and find the x-intercepts. So we're going to go through and graph this one. Okay, so I'll turn this one off. So x squared minus 2x subtract 5. So now when we graph it, oh, look, we do have x-intercepts. What are they? Okay, it's like -1.449 and 3.449, okay? So we do have x-intercepts, but with the method that you guys know how to use right now, this isn't working, okay? Okay, so with this method, it couldn't be factored, so that's what we always wrote, cannot be factored, but it doesn't necessarily mean that we can't solve it and find the roots. Okay, so are there roots? We went through, we put it in Desmos here, and again, we found when you hover over the point here, that's the point there, -1.449, and if you're wondering, that's rounded up, okay? So it does keep going forever. It's a non-terminating decimal. Same with this one. It looks like it's similar decimals, but it's still non-terminating. The decimals just rounded it up, so -3.449. So we're just going to jot those down for now. So you could just make a rough sketch on your notes here. And so this one here is -1.449. Right, and then this one is 3.449, etc. Okay, so it's a non-terminating decimal, keeps going and so forth. So, and again, if you actually wanted to see what it would look like where it's not rounded, it's not changed to decimal. This is what so you're going to find that it'll look something like this, the answer, and we're going to look at this one will be minus. And then I guess like you guys know how to simplify this radical, which I'm not going to do right now. I'll do it when we do our example. Okay, so anyway, that's just kind of it's not reduced, but that's kind of the answer that you're going to get here. So up here, you saw some really nice ones where you were getting a fraction or an integer and so forth. But now we're going to end up with ones with radicals in them today. Okay, and so I'm going to show you, so like with the methods that we know right now, we can't figure out the roots here, but there are though some. When we looked at Desmos, so what we're going to do is you're going to use this new concept called quadratic formula, and that's what's going to help you actually find the roots here when they're not nice like this, okay? Not that radicals are bad, but just lot more trickier to get to here than is to, just use your product sum table to get to the roots, okay? So, yeah, so how do we find the zeros, the roots, the x-intercepts when the equation is not factorable, okay? So the methods that we've been studying all years so far, we can't use them. It's not working here. So we would normally write cannot be factored, but we don't do that anymore. We actually will use the quadratic formula to actually find the answers today. All right, so when you have the quadratic formula looking like the quadratic relation looking like this, it's in standard form, then we can use the quadratic formula, and this is the formula that you're going to use, and I'll explain what the letters are in a sec. So yes, just make sure you're in standard form, and you're going to find like we're going to just practice this today, but tomorrow we'll look at, well, now that you have all these tools, which one's the best one to use. You'll find that this formula is a little bit time consuming, so it's not always like the first tool to go and grab when you're trying to solve for the zeros here, okay? But just for now, let's just kind of learn this tool so we have it as an option. Okay, so it'll make sense tomorrow when we look at some more examples why I'm saying the discriminant, which is this these values in the square root here, if they end up factoring out nicely, coming out to nice numbers, that means that you could have actually used a different method instead of the quadratic formula. So anyway, we'll come back to this later. Okay, so I just wanted to analyze this formula. It's always intimidating when you first see it. So it, again, like I can even show you how it came about maybe in another lesson, but for now, we have this x, okay? So that's like, how when we find the roots, it'll be like x equals 2 and x equals -5, right? So that's what that x equals blah here, okay? So, so our goal is to get to some roots. We're going to use this formula here. I'll explain the letters in a sec. Here, let's write it out again outside of the box here. Okay, so if you look at the standard form here, you will notice that we've always had the A, B, and C that we've always labeled. For the number in front of the X word is A, the one with the X is B, and the C is the one without any X's on it. And again, they could be positive or negative and so forth. So you're going to grab those and literally list them off, like when you analyze an example, list them off what the numbers are. Okay, and then you're going to go to your formula, which you have to write correctly because I'll give it to you, but I always find students always still forget a negative here or add a plus sign here, and then it just messes everything up, and it's a lot of work. So make sure you have the correct formula. Okay, write it down every time. It's a formula that you will actually use not only in math but in physics and chemistry and some other subjects. So it's a useful one, and again, you'll use it through university and so forth. So just make sure, just kind of get it memorized now, so you can kind of just always be using it, okay? All right, so A is here, right? You have B and C. So what you're going to do is you're going to go -B, and you're going to write plus minus, and then square root, all of this stuff here, B squared, 4 times A times C, all over, so all of it is over 2 times A, okay? So again, it's just like you've been doing this a lot this year where you're just plugging things into formulas. So you just got to do everything correctly and you'll do fine and you'll get the answer. If you make the mistakes, if you're not paying attention, that's where this is where people just mess up and it just becomes a big headache and so forth, okay? Before we start looking at an example and plugging numbers in, I want you to understand that there's a plus minus here. There's actually 2 equations here. See how you always get like 2 answers, right? You get like x equals 2 and x equals -5. You get 2 answers out of quadratics, right? Because again, if you're looking at, it's hitting at a couple spots on the x-axis. So there's always 2 roots, okay? So I want you to understand that this formula actually represents 2 roots. So the first one that it would represent, so if we called it, say, 1, it is negative. Okay, so the first one is, everything negative b, but then I'm just writing the plus. So whatever number you have here, you're going to add to whatever you get out of here and then divide it out by 2a. So that's one root, okay? The other root is the one where it's subtract right here, okay? clean that up. Okay, so for AC, and then make sure put that root over the whole thing, and then divide by 2a like that. Okay, so they are the same. All the letters are in the same spot. The only difference is this one was plus. So whenever you get all these numbers, you're going to add this one and get this root. And then this one here, you're going to subtract it to get this root. So instead of finding it 2 different times, you can actually find it all together like this. And then at the end, you're going to separate them into the 2 different roots where you add one and you subtract the other one, okay? All right, so just keep that in mind as you go through. Again, this plus minus is new to people. People are just like, we've never ever had to use this operation here. So I just want you to understand it's just, it's like you're going to be calculating a couple things at the same time, which is kind of neat, right? So, but it's just to save time. But if it really bugs you today, you can like calculate it separate, okay? All right, so now that you know where the A, B, and C comes from, you know the formula, we're going to actually go through an example here and find the roots, okay? So for the first one here, I grabbed this one. If you look back at the top here, it was this one here. So we used, you know, the product sum method and the decomposition method, and we did get to some roots here, okay? So we're going to now use the quadratic formula to do the same thing. Okay, so step 1, what you want to do is find your ABCs, right? So, I don't know, find ABC. Okay, so list them off. So I'm gonna just put them over here. So so again, if you need to write the standard general form here, then just write it above to remind yourself where all the letters are, okay? So A is 5, B is 17, and C is 6. Okay, and again, if they had negatives in front, you have to respect the negative and bring it along here and use it, okay? All right, so then from there, I'm going to write the quadratic formula out. So now you're going to use the quadratic formula. Okay, so negative b plus or minus b squared, subtract 4ac. Okay, again, this is a pretty complex formula, so make sure you're using all your brackets when you're subbing in these numbers, okay? All right, so again, I'm going to find them together. I know, like I already showed you that this is actually 2 different calculations happening at the same time. I'm going to find them at the same time, okay? So x is equal to, so you're going to write negative and then see how it's b. So I'm just going to remind you, put things in brackets, and I'll even use different colors here. Okay, so b is 17, so I'm putting that in. Okay, but see how the subtract, the negative here, is still there. Okay, b's been replaced. All right, then I'm going plus or minus square root of, now I'm going to go b squared. So there's that 17 again. Putting it in where the b is, and then I'm not going to forget the square. Okay, some people forget the square here. So this square is still there. All right, subtract 4 times a times c. Okay, so a is 5, c is 6. All right, and then make sure that square root goes right over. All right, and then you're going to divide the whole thing by 2a. Okay, so 2, and then what was a again? A was 5. Okay, so that's why pay attention to what letter it is that you have to sub in, because again, you might do all this work and then you're putting the B here instead of A, and then, you know, B here instead of C, and forgetting this negative, forgetting the plus, forgetting the square root. So don't forget any of that stuff, okay? Just kind of go through, do it really carefully. All right, so from here, I want you to go through and then carefully kind of clean up the calculations so we can kind of get to a nice simple answer here. Okay, so I'm going to go inside of the, think of it as like bed mass. You're going to, so we can write bed mass. Okay, so you want to deal with any brackets, okay? But if you're looking at all the ones with brackets, there's nothing you can do inside the brackets, right? So next thing you're going to go to exponents. So think of like the exponents and square root as being kind of the same level here. So we're going to take care of the stuff inside the square root here. Okay, so there's all this stuff inside the square root. So again, you can restart bed mass just inside the square root. Brackets, nothing to do. Exponents, yes, I can take care of this 17 squared. Okay, so I'm just going to write everything else out here. So this 17 is still negative 17, plus or minus. If I take 17 squared, okay, that's 289. Okay, all right, so now that that's taken care of, I'm going to take care of this part here now. So I'm just going to write the subtract like that, and I'm just going to multiply these here. So we have 4 times 5 times 6, which is 120. Okay, so I needed to subtract all of this here. All right, and then just gonna keep going here. Okay, I'm just gonna take care of the bottom here as well. We got 2 times 5 is 10. Okay, so now let's clean up the rest of the square root here. And we're gonna get that, we get 169 in here. And this is where, back up here with this comment, if your discriminant, which is, discriminant is right here. Okay, the discriminant is that b squared minus 4ac. Okay, that's what the discriminant is. Okay, so discriminant is the b squared. So if you find the number that you calculate out in here ends up being a perfect square, that means you could have used a different method, which we found did work up here. Okay, so we ended up using decomposition and it did work. Okay, so anyway, so here we're finding, oh look, there's a perfect square. There was another way to actually do this, because if you look, quadratic formula has taken a lot of steps already. I know decomposition is a lot of work as well, but you're going to probably find it would have taken less time to use this method, okay? Anyway, something we'll study tomorrow about, trying to figure out what's the best approach, okay, to problems. All right, anyway, let's keep going here. We're going to square root the 169, and if we do that, we get 13. Okay, so we're just going to keep going. Okay, and then once you square root something, right, the square root is gone. So just don't keep carrying it along once you square root, okay? All right, so give us some more space. All right, so now we've gone as far as we can now. We cleaned it up quite nicely. So now I can separate these. Okay, so I'm gonna, you know how we added one here? So we added one here, we subtracted one here. So that's what we're gonna do here. We're gonna separate these. So here's the first one. So I'll just call it x of 1. It doesn't matter which one's which. But so what I'm going to do is I'm going to write this one as I'm going to add 13 to this one, divided by 10. And then the other one will be where we'll call it x of 2. So I'll write the numbers again. But I'm going to subtract. Okay, so again, remember you have a choice between, there's add and subtract here. So we're just separating the add and subtract now. Okay, so here are, so again, these separated and became 2 different roots here. So, and the only difference is I'm going to add the one and I'm going to subtract the other one to get my 2 roots. Okay, so when I do that, so you're going to get 17 added to 13, the battle, negatives are going to win by 4, right? Sorry, negative 4, there you go. And this one here, these two, they add up, and then you end up with negative 30. Okay, and then from there, you're just going to reduce these, so you get negative, you can divide a 2 out of both of these, 2 over 5, and then you get negative 3. Okay, and that's what you had up here at the beginning. You had the negative 3 and negative 2 over 5 using the decomposition method. You just now threw quadratic formula at it. Took a lot of work, yes, but you did get the same results as well. Okay, so be able to use this method as well, because this one I picked the specific example because I knew the answers weren't too bad. There weren't any radical answers, so I just wanted to use that to start off with, okay? All right, so we're going to do another one here where you're going to end up with a lot messier answer here, and I'm going to show you how to simplify it. I forgot to write in the instructions here, solve. I should have written solve. So whenever you see that, you should know, oh, what do I do? Okay, solve means I have to find those roots. Okay, so I shouldn't have to explicitly write find the zeros by using the quadratic formula or factoring method and stuff like that. You just need to know, oh, I got to find those zeros. Okay, so I have to figure out what values of x will actually work in here to make this whole equation equal to 0. That's what you're literally finding here, okay? These two numbers, you can put this one in and it'll equal to 0. You can put this one in and it'll equal to 0. Okay, so there's two possible answers here. Okay, so let's move on to this one. So again, I know with the factoring method, you always look for the greatest common factor, and then you use it, and then you plug it in and so forth. If you can do that still here, but you can actually just go right to this, find the ABCs and plug it in, and yeah, it'll work without finding the greatest common factor. Okay, all right. So I'm going to skip that method. I'm not going to find the greatest common factor because I do see one here, like a 2 would work. Okay, so just go right to finding ABC here. Okay, so A here is 2. B is 4, and C is -10. Okay, then if you wanted to find the greatest common factor, you can. You end up then working with nicer, smaller numbers. So that's an advantage, I guess, if you wanted to do that. All right, so again, I'm just going to kind of just keep it similar to what I did here so that it's not too overwhelming when you're learning this. So, so again, A, so you're finding A, B, C, right? Okay, list them off. All right, and then I'm paying attention. That's +2, that one's +4. This is -10. Make sure you bring that negative along, okay? All right, now we're going to use the quadratic formula. Okay, so again, you're going to write it down correctly. So just before you go to use it, just write it down and you'll get it memorized by, maybe the third question, okay? Okay, so we have x equals -b, plus or minus square root of b squared, subtract 4ac, all over, you're going to divide by 2a. All right, so let's go through and plug everything in. Again, I'll use different colors here just to make sure you're plugging things in the right spot. Okay, so b is 4, so I'm going to write this negative and then the 4 in brackets here. And then plus or minus, because we are dealing with two equations at the same time that will separate at the end. And then we have b is 4 again. And then don't forget to square. Don't forget the square here, okay? And then subtract 4. And then we have AC. A is 2. C is -10. So watch out for that. Okay, and then let's pull this square root over. Okay, and then 2 times A. A is 2. Okay. All right, so here we go. So we're going to go through and clean everything up. So this is -4 plus or minus. Okay, so I'm going to do the square here, 16. All right, so now this is the part we have to be careful with. So again, there's lots of different ways you can calculate this, but we're just going to all make sure we're getting it the same way, okay? All right, so I'm going to write the subtract here, okay? And then I'm going to just take care of this part here. I'm going to take care of just this part here and multiply those out, okay? So what is 4 times 2 times -10? Okay, so you get -80. So what I want you to do is you're writing your subtract, and what you did here, and then maybe I'll just write this as orange here or yellow. Okay, so 4 times 2 times 2 is 8 times 10 is -80. So you're going to write that -80 here like that. Okay. So this is important because you get a negative, and the people don't know if it's, oh, am I subtracting it? Am I subtracting 16 minus 80? No. So you have to make sure respect the subtraction that's already there, and then you have a -80. So you have to clean this up, and you get plus. Okay. So just watch out for that when there's a negative for one of these here. Okay. So I'm just going to take care of the bottom here. That's 4. All right. So this all cleaned up to, I'll just write it again. (16 plus 80), like that, all over 4. Okay, so again, this alone was negative 80, and then it's like, okay, well, the subtract is here still. So once you clean all this up, a negative 80 is still sitting here, and then you need to clean this up and make it positive 80, like that. Okay, so then in the end, you're adding to 16 here. You're not going to be multiplying 80 to 16 or subtracting 80, okay? So it becomes plus 80 here. So just be careful with that. That's another place where I see a lot of mistakes get made here. They just don't know what to do when this turns into a negative, okay? All right, so keep going. So 16 plus 80 is 96, okay? And 96 is not a perfect square. So right away you just think, okay, I'm using the right method here, okay? Because I know this one, if I tried to factor it, it would, yeah, it wouldn't have worked, okay? You needed to use this method here. All right, so let's go now. Now we're at the step here where, okay, now we're like, oh, actually, so if you try to take the square root of 96, you end up with a decimal 9.79 and so forth. And again, I don't want you to go to decimals, so I want you to, I guess this year I just said, okay, this is as far as you go, just stop and just write your answer in radical form, okay? So I want you to write this. Now separately, we're just going to put the add here. Okay, so that's your first x, and then the other root that you can make here is the one that's subtract. And it doesn't matter if you wanted to write the subtract first and then the add second, it doesn't matter. So just that you're writing them separately now, and these are your roots, okay? So I know I didn't make you go through and simplify this radical, but you will do that a lot next year, so just keep that in mind. If you know how to actually reduce it, go ahead and actually try that. So I'll get you to do it down here. Okay, so again, this is okay for you to just stop here. Okay, so let's just, if we wanted to keep going, because I know a lot of you were still trying to practice finding the root here. You can do that. So just think of 96. What two numbers multiply to make 96? That you could use here, but one of them is a perfect square. Okay, so just kind of brainstorm for a second, and when you think of it, write it down. Okay, so here, the 96, a couple numbers that work really nice to make 96 is 16 times 6. Okay, so I don't know, maybe we should do this separately here. So I'll just do it here. Okay. So if we're just doing an aside here, okay, just doing some work on the side here so that we could kind of simplify this out. So you know 16 times 6 works nicely. So again, remember it's like I can square root both of them then. And 16 is a perfect square, so a 4 comes out. I'm not going to write the square root anymore. So it becomes 4 root 6. Okay, so that's what 96 can, so you're just simplifying your radical here, right? Okay, all right, so now we can put it back into the question here. So again, you can stop here, but if you just want to keep practicing simplifying your radicals that we learned earlier this year, you can put it back in as 4 root 6 instead of root 96. Okay, and then when you do that, see how they're, it's like they're all over 4. So, you know, you can write it like this. This one's over 4, and this one's over 4, root 6, like that. Okay, so you can see the 4's will cancel out, and then you end up with -1 plus root 6 is your final answer. Okay, all right, and then here, subtract 4 root 6 all over, whoops, I made a mistake here. It should have been 4, okay, because we had 2 times 2, yeah, sorry. And then we are going to, and then you saw how it's simplified here, so I'm just going to simplify here. So this become negative subtract negative 1, subtract root 6, like that. And so those are your two roots for this one, okay? And so what you're going to find if you graph it in Desmos, you're going to end up with those, like the non-terminating decimals here, okay? And that's why, like, so the quadratic formula can find those quadratics where you have the roots that look like this, where they are just decimals that go on forever, okay? So the ones that were like this, I know you have a fraction here, and I know it becomes a decimal, but it just becomes 0.4. So it's a nice terminating decimal, right? So these are just nicer looking answers, but they're, a quadratic can go wherever it wants, depending on what the equation is. So you can get ones where they just, they land just somewhere in between the lines and so forth, okay? All right, so now you know how to find the roots when you have a quadratic that looks like that. And yes, the roots will look like this, but in the end, I'm okay in grade 10 if you guys just keep it here, okay? If you just went this far and just stopped and left your answer in radical form, that's great, just stop there. But I know a lot of you actually quite enjoyed simplifying the radicals, so I know that I want you to kind of go ahead and practice, like once you get to here, go ahead and practice and try to attempt to simplify the radical out to get to a more simplified answer here like that, okay? So this is another answer here, but I just, again, I'm okay if you go this far. All right, now that you've seen one, I think let's look at a few more examples. Yeah, and then this is definitely something that you need to practice with. You just can't look at it, try it once, and be done with it, okay? So it takes a lot of just patience and putting numbers in the right spot and being really careful with all your integer operations, double checking every step before you keep going, okay? All right, and then from there you could, if you wanted to double check if you got the right answer, is that you could actually go through and square root 6. Okay, so that becomes so the square root of 6 here is 2.45. Again, it's non-terminating. So if you were to put that in here, you would get 1.45 for this one, and then you would get, for this one here, you get negative 3.45, okay? All right, so yeah, so that's, and if you actually graph it, that's where those dots will be, and then you can double check in decimals if you did it right, okay? All right, so let's move on to the next one here. So with quadratics, the tools that you already have under your belt are, you can solve your way to the answer, you could factor your way to the answer, and then if you can't use those, you should use quadratic formula. So hopefully you saw from up here, it's a lot of work. This method is a lot of work, but yes, this method can actually find the answer for all the quadratics. Like everything that you've been doing, like if you've been finding factoring challenging and you can't get to these answers because you're having trouble factoring, this method, the quadratic formula, will get you to the answers every single time. Okay, so it's nice, but it takes a long time and it takes a lot of work and it takes a lot of being careful and so forth. So again, have it as one of your tools, but don't have it as that first tool to grab, okay? So see if you can try the other methods before you use this method, okay? Anyway, but again, we'll practice that tomorrow. So let's get to here to the next two. If you feel like you've got these, feel free to skip to E and F in the video, okay? Because these are, I picked these ones specific because they're a little bit different, okay? But C and D is just a couple more to just practice the formulas, okay? All right, so step 1, A, B, C. Go and find those. All right, so list them off. Okay, 5, B, -4, C, -3. Okay, that way you're reminded, all right, there I have some negatives there that I have to make sure I pay attention to. All right, step 2, the quadratic formula. Okay, so go through, start writing that out. And then maybe, I don't know, just let the video play and work ahead and see if you get the same answer as me, because I have to write slow here. All right, so we have b, negative b, sorry, plus or minus b squared. Subtract 4ac, all divided by 2a. All right, so we are, again, we're still solving these, okay? So solve means go and find those roots. Find the x values that will work here. Those are the x-intercepts. All right, so I'm going to go with b. I'm going to not write in the colors. Unless, I don't know, maybe I will. All right, so b is negative 4, okay? So see how it's negative? So make sure, put that negative in there. But also, this is the negative that was already there in the formula. Don't just suddenly let it disappear, okay? All right, then plus or minus b squared. So again, negative 4 is in brackets. That's why you put things in brackets, because those negatives can mess things up. All right, squared, and then you have subtract 4ac. A is 5, c is negative 3. Okay, so don't forget any negatives accidentally. All right, so there. All divided by 2a. A is 5. Okay, so now we are going through and we're simplifying this out. Okay, so here, again, we remember this negative and we also know that b is negative 4. So now at this point you can clean up these two signs. Whenever you have two negatives together like that, it's positive. Okay, so that becomes positive 4. All right, this plus or minus is still there. The square root is still there. Negative. Okay, so now I have this negative 4 in brackets squared. Okay, so that means this exponent 2 owns this. So it's negative 4 times negative 4 is positive 16. Okay, so again, if you make an operation error like that and write minus 16 here, this whole thing explodes and you're going to get the wrong answer after doing all this work. Okay, so be careful here. So that's why I put things in brackets. This exponent 2 owns this, so it's negative 4 times negative 4 is positive 16. All right, here is another issue again. Here's a negative again. So you know it has to be subtract. Okay, so now we're looking at, all right, what does this answer end up as? So leave the subtract, let's just go 4 times 5, which is 20, times 3, or negative 3, is negative 60. Okay? All right, so be careful with that. Now you see that this negative here cleans it up and it becomes plus 60, right? So just be careful with that. All right, so I'm just going to clean up the bottom here. 2 times 5 is 10. 10. Okay, so keep going. So I have a positive 4. And this is plus 60 like that, okay? I'm just writing all the steps out so I don't leave anyone behind, okay? You don't have to write this many steps. Okay, so from there, you have to clean up the square root still. So you get 76, and you start thinking in your brain, is that a perfect square? No. Okay, so this was the right method to use. Okay, so now you can write them separate, okay? You've cleaned it up as far as you can go. This isn't a perfect square. So here's my first root. It is where I add this, the radical and put it over 10. And then the other one is where I subtract the radical and put it over 10. Okay? All right, so then feel free as a grade 10 student to stop there and say that's your final answer. Okay? But let's be nerdy and see if we can reduce the 76 here. So again, so you're just brainstorming right now. 76, what nice numbers work for 76? Okay, so we're finding 4 is a nice perfect square. So again, I'm just circling this to say you can stop there, okay? All right, but let's keep going here for fun. So 76 you can have, so where can I do this here? I'll do it over here. Here's my little side here. So we're just trying to break 76 down. So the root of 76 breaks down nicely with a 4 times 19, okay? So again, it just takes practice to brainstorm what numbers work. You can just sit there and crunch them on a calculator, and I just kind of, yeah, found 4 right away, and it worked, okay? And I know 19 can't break apart anymore, so, but yeah, you'll practice lots of these next year, so you'll get fast. All right, so that means I can square root both of them, but the 4 can square root because it's nice, so I'm going to write 2. I'm not going to write the root anymore. 19 stays in jail. Well, it's not that it's a jail, but it's a root here, stays there, and you're left with that, okay? All right, so now we can go through and simplify this out. So we have 4 plus the root of 219 like that over 10, and then 4 subtract 2 root 19 over 10. Okay, all right, and then so you're thinking, okay, you know, like the last one came out nice, it came out to a 1 and stuff, but this one here, it's more just reducing the fraction down, okay? So you should be able to, here, I'll just write them separate like this. I'll do that one in a sec. Okay, so here you should be able to reduce it down to a smaller fraction here. So take a 2 out of both of those, you get 2 over 5, plus this one here becomes 1 over 5, which is the same as writing it as root like that. Okay, and then here, and then I don't know, like some people like to write it as one denominator. So you can write it like that as well, okay? All right, and then here, so same thing, you can go to subtract root 19 all over 5. Okay? All right, so just give yourself a challenge, keep reducing it down, and this way you practice your simplifying your radical stuff that you'll use a lot next year, okay? All right, but again, feel free to just stop at the yellow. Okay, let's do another one here. Okay, so again, you don't need to take out the greatest common factor, but you can if you want to. All right, so when there's no number there, it's a 1. Make sure bring the negatives. There's a negative. It's important. You can see that there's a lot of work that is involved here, and if you mess up with the negative, it's going to be really frustrating, you know, doing all that work and not getting the full marks, okay? All right, so I found my ABCs. I'm now going to use my quadratic formula here. And you're just going to plug everything in. Okay, so again, see if you could just work ahead of me and get to the right answer before I get there, okay? All right, so I'm going to use my different colors here. Okay, so we have a -4 being subbed in. Okay, don't forget any little details. Okay, it's about, a lot of the stuff this year is about just being really careful and meticulous with everything. And yeah, but it's not too bad. It's just, as long as you're careful, you'll get to the answer. Okay, so there, everything's been plugged in. Again, sometimes you get a little bit sleepy and you might plug the wrong letter into the wrong place. So just double check, okay, the B's one in the right place, A, C, yep, good. And then 2 times A, which is 1. And again, you're like, I don't even need to know that stuff. I know that's going to be 2, yes. So just kind of, yeah, just simplify your work here. You don't have to write everything out like I do, okay? All right, so go through. All right, so again, that cleans up to +4, plus or minus 16, and then so as long as you know it's going to be an add or subtract in here, see how like this negative and that negative, right? It's going to become a positive. So 4 times 1 times 1 is 4, right? And it's like negative, negative, +4, okay? So if you can do that, that'll work a lot faster, okay? Otherwise, I would have just gone through and went minus, and then you would have had a -4 that popped out that you would have to write +4 on anyway. So, okay, so there we go. and now we're cleaning it up here. So root 20. So again, I'm like, oh, okay, I know I used the right method because I don't get a perfect square here. Okay, when you do, that means you could have used decomposition or just, product sum, simple trinomial factoring, and so forth. Okay. All right. Yes. Okay. So now we are at the stage where we can pop out the two equations. So here's one. One of them will be 20, like adding 20, and the other one will be subtracting 20 from 4. Okay, so hopefully you're getting comfortable with the fact that this quadratic formula is actually getting you to calculate two things at the same time, and then you're separating them. So one's where you add it, and one's where you subtract it. And then again, you can just stop here in grade 10. Yeah, let's, get ourselves ready for next year. You found that simplifying this 20 isn't too bad, right? So let's do an aside here. Okay, so root 20, what two numbers work here? Okay, so 4 and 5, hopefully you thought of those quickly. Okay, so that means you can root both of them, and the 4 becomes 2. The 5 stays behind inside the radical here, okay? All right, so let's simplify this out then. So you're going to have 4 plus 2 root 5 all over 2, okay? And this one is going to be 4 subtract 2 root 5 over 2. And it's a nicer one to reduce, okay? So 4 and 2, right? That becomes 2. And then 2 divided by 2 is just 1, so it just becomes root 5. Sorry, this is root 2. And, oops, this one will become 2 subtract root 5. Okay? All right, so you're just going to simplify it out for fun. But yeah, you can leave it here like that. Let's just practice, what if you had to write decimals? Okay. Okay, so what if I wanted, like we were doing a word problem and I actually wanted, the answer to so many decimal places and so forth. So then I want you to go ahead and calculate this out. So all you're going to do is you're going to write 4 plus root 20. So if you put that in your calculator, 4 plus the square root of 20, it equals, you get 8.47, and then you're going to divide by 2. So again, your answer would be 4.24ish if you rounded up. So please try this right now on your calculator, see if that you're getting the same values, okay? So I do want you to keep things in, a simplified radical form, but be able to also tell me the decimal answer as well. Because when you go to practice these today, your textbook will have them have decimal answers. Okay, so that way you can double check your work and so forth. Okay, all right. So those are the numbers that you should get if you actually convert them to decimal form. Okay, and then if you go on to decimals, you can see, oh yeah, these are the x-intercepts as well. Okay, so hopefully after this many, you're feeling confident, okay, and you know what to do. It's just a lot of work and just being careful, okay? All right, let's get to the last two. I picked these ones because they're just a little different from the other ones that we did. So what you're doing here is you're still going through the same steps here. I'm giving myself lots of space because that takes a lot of space. Okay, so start with ABC. So A is X. No, it's not. It's 1, sorry. It's 1. B is 3. C is 7. Okay, all right, we're going to use the quadratic formula now. Okay, so B is 3. Here, sorry, I should write the colors in. Okay, there it is. And plus or minus b squared. I'm just going to write the other ones in because I hate switching the colors here. A, C, there we go. Okay, so b squared, subtract 4a times c, all divided by a, 2a, like that, okay? All right, so we're going to go through here. Oops. Go through here as usual, cleaning stuff up. So we have 9, subtract, okay, 4 times 1 times 20, or 7 is 28. Okay, and then you get to there. All right, and then we're going to take care of this part here. Okay, and then this is where you have to stop. Okay, so remember how I told you look for what's in here. If it is a perfect square, that means you could have used one of the other methods and taken a lot less time. If you do get something like a number in here that's a positive number, then you just kind of carry on and you find your answer. But if you get a negative, that's not good, okay? So the discriminant is negative, right? Remember the discriminant is what was inside the root? The discriminant here is negative, okay? So just stop. So if that's the case, just stop, okay? So what you're going to do here is you're going to write, okay, so actually don't write that. Okay, so write, there are, okay, so there's no roots, no real roots. Okay, so you just stop and go because, you know, the discriminant. So if you actually try to take the square root of a negative on your calculator right now, so go ahead and try it, you're going to find it'll just say error, okay, or I don't know what your calculators are usually right. I don't know what a phone will, but it'll just say error, okay, or or I think, yeah. So just stop. If you know you did everything correctly, you put everything in correct and so forth, and then you get this. That just means that there are no roots. So I'm just going to show you what that looks like visually, okay? So let's find the equation here. All right, so let's go to Desmos here and plug that in. So if I put in x squared plus 3x plus 7. Okay, so that's in there now. Yep, okay, so now I'll just zoom out here. So I'm just, oops, I think I did something wrong here. So x squared, oh yeah, so I have an equal sign. All right, so sorry, plus. Okay, so now I can graph that. So if you take a look here, yes, we still have a quadratic. It looks like a normal graph that we've been studying. So what's different about it? Does it actually hit the x-axis? Okay, so if I zoom out, sorry, shift it over. So see how it's not even hitting the x-axis? So when I ask you to solve this for this quadratic, I'm asking you to find the x-intercepts here. So like if I turn this one on, this one here, remember it had x-intercepts that I could read off. This one here, so you can have some quadratics that are up here like that. They will never hit the x-axis. So in this case here, that's what happened. Okay, that's why when you're going through and calculating it, you can't actually get to the root. Nothing will work here. And so you say no real roots, okay? So that's what you do in grade 10. You learn grade 11, 12 that there are imaginary roots. But for now, we're just studying things in the real world and real numbers. But there are imaginary numbers, okay? So for now, that's all we write. We just stop and go, oh, okay, discriminant, this is negative here, so there are no roots here for this one. And then you'll get the full marks, okay? And again, this is why, just because you don't see the quadratic come down and actually hit the x-axis, okay? All right, so that was one that I wanted to show you just to be careful with, okay? So if that happens, don't freak out. Just if you know you did everything correctly, then you just stop and say, oh, this one doesn't work. There's no real roots. All right, and this one here, what's special about it? I guess it's like any of the other ones. I just wanted to show you, just be careful, like this A is negative and sometimes that can happen. So just make sure don't forget any of the negative signs, okay? All right, so but if you feel like you got this, go ahead and stop and then go practice some questions and try the checkpoint. All right, so, but if you need a bit more practice, oops, I don't know why I'm writing a square here. Okay, so go through and try one more here. And hopefully after doing this many, you've got the formula memorized. All right, plug everything in. Again, start off with like actually listing everything correctly. If you mess up this step, then the whole thing is toast as well. So just be careful. All right, so we have b, which is 12, plus or minus. We have b, which is 12, and I'm writing everything else here. A, C, and then I have a at the bottom. Okay, there. Okay, so I'm going to write 12. So negative b, there it is, plus or minus square root b squared, subtract 4ac, all over 2a. Okay, all right, so let's go through. So we were just being careful that we had all of the negative signs in the right place here. Okay, so that's negative 12. 12 squared is 144. All right, we've got lots of negatives here, so watch out. So we have negative times negative times negative, so we know it's going to be a negative answer here. And then we have what, 12 times 7, which is 84. Okay, so again, 4 times negative 3 times negative 7 is negative 84, or positive 84. And then now you have the subtract here, so subtract 84. So just be careful there. And then this is negative 6 at the bottom. Okay, so lots of negatives here. Just be careful. All right, so let's clean that up. So it's looking good in here. Whoops, you know that you're not going to have a negative discriminant, so that's good. So just go through and then, you know, we don't get a perfect square, but so we know that this is the best method to use. Okay, so I gotta get a root 60, okay? All right, so how do we write this now carefully? So here's the first one. So we have 12 adding the root 60, all divided by negative 6. And then we have negative 12, subtract the root 60, all divided by negative 6. All right, so there are the two roots. Feel free to stop there. Okay, but yeah, let's just keep going here and cleaning this up. Okay, so I'm thinking about 60. What numbers work well for 60 here? Root 60. Okay, so you're thinking 10 times 6. No, those aren't perfect squares. But 4 and 15 work. Okay. And then if you square root them both, you get 2 root 15. Okay. All right, so go through, replace the root 60. With 2 root 15 all over 6. And this one is 2 root 15. Oops, don't forget the negative 6, right? Negative 6, like that. Okay, so let's clean this up. There's a lot of negatives floating around here still. So it's like I'm going to write these separately. So these two here will become 2. And then here that'll become, oops, it'll become, here, I'm going to write them separately. It's going to get confusing here. Okay, so okay, so the negative 6 is underneath both of them. So for this one here, you'll get positive 2, and then here it'll become negative, and then this reduces to 1 over 3, which you can write like that, okay? And then so same with this one here. It'll just be 2, and then it'll be plus 15 over 3, okay? And then don't divide the 15 and 3 because the 15 is inside of the square root, okay? All right, so there's your simplified radical answers. But otherwise, yeah, you can keep it like that, okay? All right, so I have a couple textbook questions that you can get more practice with. So again, the answers are in decimal form, so just practice getting it to the reduced form, and then you can change it to decimals just to check to see if you got it right, okay? But yeah, just remember to keep it as a reduced fraction or radical form here for grade 10 academic, okay? All right, so hopefully after all of these examples, and then this one where it didn't work, so you don't panic when you get to the one where the negative occurs inside the square root. Yeah, hopefully from here you can apply the quadratic formula when you need it, okay? So again, with this one, don't stress. Like you're going to go through and calculate and go, oh, hey, it's that one where it's a negative, and then you know to go, oh yeah, this is the one with the no roots. Otherwise, everything else should work. This formula can get to the root, okay? Regardless of how messy it gets with all the radicals and so forth. But again, just like we did with the first example here, even those nice ones that you can factor out using decomposition method, right? You can, or even like this one where it was a simple trinomial, where it quickly get to the roots. You can use the quadratic formula to find the roots for this. But hopefully you're seeing here it's a lot more work to use quadratic formula, but even though it'll get you to these roots. So yeah, so just just add it to your toolbox. Have it there, but kind of use it as that third one, okay? Like kind of try the other ones first, and then if they don't work, then use this tool here, okay? All right, so yeah, get good at these. You're going to use them a lot in the future, so yeah, and then try the checkpoint.